The paper of the day is In Search of an Understandable Consensus Algorithm. RAFT is a consensus algorithm for managing a replicated log. It produces a result equivalent to multi-Paxos, and it is as efficient as Paxos, but its structure is different from Paxos. This makes RAFT more understandable from Paxos and also provides a better foundation for building practical systems. In order to enhance understandability, RAFT separates the key elements of consensus, such as leader election, log replication, and safety, and it enforces a stronger degree of coherency to reduce the number of states that it must be considered. Results from a user study demonstrate that RAFT is easier for students to learn than Paxos. RAFT also includes a new mechanism for changing the cluster membership, which uses overlapping majorities to guarantee safety. Authors have implemented RAFT as part of replicated state machines that stores configuration information for RAM Cloud and assists in failover for the RAM Cloud coordinator. The RAFT implementation contains roughly 2,000 lines of C++ code, not including tests, comments, or blank lines. The source code is freely available. There are also about 25 independent third-party open source implementations of RAFT in various stages of development based on drafts of this paper. Now let's look at the contributions. RAFT is similar in many ways to existing consensus algorithms, but it has several novel features. Strong leader. RAFT uses a stronger form of leadership than other consensus algorithms. For example, log entries only flow from the leader to other servers. This simplifies the management of the replicated log and makes RAFT easier to understand. Leader election. RAFT uses randomized timers to elect leaders. This adds only a small amount of mechanism to the heartbeats already required for many consensus algorithms, while resolving conflicts simply and rapidly. Membership changes. RAFT's mechanism for changing the set of servers in the cluster uses a new joint consensus approach where the majorities of two different configurations overlap during transitions. This allows the cluster to continue operating normally during the configuration changes. Let's start PS score for this paper. Overall, this paper is a decent read, so it gets 9 out of 10 on readability. With 18 pages long, it scores 8 out of 10 on length. It's a research prototype with pretty good description, so that makes it 9 out of 10. Its learning meter and industry value is pretty high, so it gets 9 out of 10 on each with overall PS score of 9 out of 10.